Cybernetics Made Easy, Part 4, The Governor, Information and Energy, by Robert Johansson. We began with a diagram of the governor on a steam engine, with its boiler, its steam valve, its steam engine, its drive shaft, its gear, its spindle, its fly balls, its sleeve, and the lever that goes back to the valve, controlling the steam. We then translated the diagram into a schematic of the process. The changes in the drive speed are translated by the gear into perceptions, or the speed of the spindle, which is then translated by the fly balls into needs, or a change in the sleeve, which means faster or slower, which is then translated by a lever into action, a change in the steam valve position, which then sends steam to the steam engine, which changes the drive speed. Each of the translators has both an information aspect and an energy aspect. It both transforms and transmits the information. Thus, choices in set A are translated as an information process into choices in set B. Information is choice within a set. Form is a subset of geometry, which is a subset of mathematics, which is a subset of logic. Logic is about choices, or categories. Communications people refer to this translation process as coding. Mathematicians call it mapping. The map is not the territory, but the territory is the meaning of the map. Now, for the energy process, energy in joules is translated by the energy process into energy in joules. Energy is a quantity measured in joules or calories. Energy is a universal constant, therefore energy processes are equations. Thus, we look at the steam engine as a translator. In the information process, we see that a change in the position of the valve is translated by the steam engine into the changing speed of the drive. The changing position of the steam valve is mapped onto the changing speed of the drive. The changing speed of the drive is coded information about the changing position of the steam valve. On the other hand, the energy process has energy in the form of steam minus entropy is equal to the energy in the drive. The full quantity of the energy of the steam is not transferred to the drive because no heat engine is 100% efficient. We can see that the valve's position sends a message to the engine that the engine translates into drive speed. The energy of the steam is a medium for transmitting that message. The reduction gear as a translator. If we look at it as an information process, we see that the changing speed of the drive is translated by the gear into the changing speed of the spindle. In other words, the changing speed of the drive is mapped onto the changing speed of the spindle. The changing speed of the spindle is coded information about the changing speed of the drive. On the other hand, if we look at it as an energy process, we see that the energy in the drive minus the energy in the load is translated by the gear into energy in the spindle. The full quantity of the energy of the drive is not transferred to the governor, but only a small part of it. The energy is merely a medium for transmitting the information. The flyball's a translator. Looking at it as an information process, the changing speed of the spindle is translated by the flyballs into a changing position of the sleeve. The changing speed of the spindle is mapped onto the changing position of the sleeve, and the changing position of the sleeve is coded information about the changing speed of the spindle, which is coded information about the speed of the drive. Now the energy process, you can see, once again, the flyballs translate. On the one side, you have the energy in the spindle minus the energy in the flyballs equals the movement in the sleeve. The full quantity of the energy in the spindle is not transferred to the movement of the sleeve because some of that energy is taken up by the flyballs. We can see that the speed of the spindle sends a message to the sleeve about whether the engine is speeding up or slowing down. The lever as translator. Looked at as an information process, the changing position of the sleeve is translated by the lever into the changing position of the valve. The changing position of the sleeve is mapped onto the changing position of the valve. The changing position of the valve is coded information about the changing position of the sleeve, which is coded information about the changing speed of the spindle, which is coded information about the changing speed of the drive. Now the energy process with the lever is the movement of the sleeve is equal to the movement of the valve. And it follows the standard formula, F1 times D1 equals F2 times D2. The full quantity of the energy in the sleeve is transferred to the valve. The leverage ratio will determine how much of that energy is force and how much distance. The lever allows the sleeve to send a message or command to the valve to add more or less steam. Positive and negative feedback. The lever has two options. The lever can be hooked up to the steam valve so that an increase in the speed of the drive shaft can cause the lever either to increase the flow of steam or to reduce the flow of steam. Positive feedback. If the lever translates the increasing speed of the drive into an increase in the flow of steam, this is called positive feedback. It amplifies the change. Similarly, if a decrease in speed is translated into a decrease in steam, the change is amplified. Negative feedback. If the lever translates the increasing speed of the drive into a decrease in the flow of steam, then this is called negative feedback, or a homeostatic system. It seeks to maintain a constant value. Thus, a decrease in speed leads to an increase in steam, and the system oscillates around a set value. The energy processes are the media for the information. The governor has both an energy process and an information process. Since a control process is an information process, our concern has been with how a message about the speed of the drive is transmitted to the spindle, whose flyballs translate it into a move of the sleeve. Through the lever, the movement of the sleeve is translated into the movement of the valve. Thus, information about the speed of the drive is translated into a command to the valve to either add or reduce the steam, which the steam engine translates into an adjustment of the speed. The energy process acts as a medium for transmitting information. The information controls the matter and energy. Control systems control matter and energy. Thus the flow of the steam and thus the speed of the drive is controlled by the valve, which is controlled by the commands it receives from the sleeves. And the sleeves movement is an evaluation of information about the drive and a decision about whether the drive is going too fast or too slow.